Welcome back to the deep dive. Today we're zeroing in on a piece of tech that sounds, well, maybe super specialized, but it's actually the hidden engine behind a lot of those big visual experiences you see every day. We're diving into the WolfPack 4K 30Hz 32x32 HDMI Matrix Switcher. Now, that 32x32, I mean, for anyone in AV, that number jumps out. 32 HDMI inputs, right? And you can route them to 32 HDMI outputs independently. So yeah, it's about moving signals, but it's really more about orchestrating all that visual information, our mission, unpack what this WolfPack thing really does, why it matters, and, who actually needs this kind of power.
Yeah, and what's really fascinating, especially if you track AV tech, is how the sheer amount of video screens everywhere demands these really sophisticated, really reliable ways to manage it all. It's not just plugging a couple of things in anymore. It's about building this visual ecosystem.
Yeah.
And the WolfPack, it's right in the middle of that.
That's a great way to put it. Because, Matrix Switcher, people hear that and think maybe it's just a splitter or a simple switch, but it's way smarter. Think of it like, less like a simple traffic cop, maybe more like air traffic control. For dozens of video feeds, you're not just sending one thing to many screens. You're taking any of those 32 sources, sending them to any of the 32 screens, any combination, all at once if you need to. That kind of control. It's a whole different ballgame for big setups.
Right, and that immediately brings up a really important question for anyone designing these systems. How do you manage all that flexibility? Routing all those signals without messing up the picture quality or introducing lag or running into compatibility issues across potentially 32 different kinds of screens. The whole point of a 32x32 matrix like this WolfPack is handling that dynamic connection. Imagine like a command center. You need live news on screen 1, critical data on screen 2, maybe a presentation on screen 3, all from different places, all needing to land on the right display now. That's what independent routing gives you. The right info, right place, right time, every time.
Perfect example. Okay, so let's dig into the specs a bit, the things that make this performance possible. The headline, obviously, is 32x32. Those 32 female HDMI inputs, 32 female HDMI outputs. I mean, just think about cabling that. Even a small multi-screen setup gets messy fast. 32 channels, that tells you who this is built for. Then there's the resolution, 4K 30Hz. And it specifically mentions 4.2.0 color sampling. So 4K, we get that super sharp picture. But the 30Hz and this 4.2.0 thing, why that specific combo for professional use instead of, say, 4K 60 Hz with maybe 4.4.4 color? What's the trade-off there?
That's a really key point. It's all about optimizing for the job.
Yeah.
4K 60 Hz with 4.4.4 color. Yeah, that's the absolute top tier visually. But it eats up a ton of bandwidth. For a lot of these big professional environments, think digital signs, control rooms, sports bars, the main content might be video feeds, maybe presentations, data, stuff that looks great at 4K 30 Hz 4.2.0. You get excellent quality, but you use way less bandwidth. That makes transmission more reliable, especially over longer cable runs or through complex switching gear like this. It's a really practical balance. Quality, reliability, system cost. It keeps things stable across all those outputs. Trying to push 4K 60, 4.4.4 through 32 channels, that gets expensive and tricky fast.
Okay, that makes total sense. It's about what's practical and reliable for the scale. And speaking of performance, 1 second switching time. That sounds quick, but is it just about avoiding a black screen for a second, or is there more to it? Why is that speed so critical in some places?
Oh, it's way more than just avoiding a black screen, especially in critical spots. Think about air traffic control or an emergency operations center, maybe a busy trading floor, places where literally every second counts. A 2-second delay. That could mean missing a crucial warning, misinterpreting fast-moving data, real consequences. The WolfPack speed means the visuals are essentially real-time. It takes visual lag out of the equation in high-pressure moments. Operators can react instantly. It's about operational integrity, safety even.
Taking latency out of the equation, yeah, that's a big deal. Okay, and then we see HDCP 1.4 and HDMI 1.4 compliant. Can you break down why those specific versions matter for a system like this?
Sure. So HDMI 1.4, that's the standard that really brought in support for 4K at 30 Hz. So it matches the switcher's core capability, makes sense. HDCP 1.4, high bandwidth digital content protection, that's absolutely vital. It's the encryption key, basically, for copyrighted stuff. Think sports bars showing the game, corporate boardrooms showing licensed content. You need HDCP for the source and the display to talk securely. Without it, you just get an error message. Or blank screen, no picture. So being HDCP 1.4 compliant means this box is ready to handle pretty much any professional content source you connect. That's essential.
Got it. So compliant and secure connections are table stakes.
Yeah.
Okay, moving beyond just speed and resolution, this thing is built for reliability too. It mentions a chassis and four-port cards design with hot swappable I/O cards. That sounds technical, but sounds like a big plus for keeping things running.
Oh, it's huge, that modular design. It's a game changer for uptime and, honestly, for the total cost over the life of the unit. Imagine a regular matrix switcher, right? One single input port dies. What happens? Often, you got to power down the whole thing, pull it out, send it for repair. Could be days, weeks of downtime. Critical systems can't afford that. With this WolfPack setup, hot swappable cards. Say one input group goes dark, you figure out which four-port card it is, you pull just that card out while everything else keeps running and slot a new one in. It's like changing a tire while the car's still rolling down the highway. Well, almost. It slashes maintenance time, keeps the operation going, and saves a lot of money and headache compared to a full unit failure. Plus, maybe you can upgrade cards later. Adds flexibility.
Wow, okay. That is a critical difference, especially where downtime is just not an option. So you've got all this power, all this flexibility. How do you actually control it all? It lists the usual suspects: front panel buttons, IR remote, okay, RS-232, TCP/IP for network control, standard stuff. But then what caught my eye were these optional control packages, like a sports bar TV control package and something called WolfPad for controlling TVs from a tablet using a floor plan view, both around $2,500 extra. How do those fancier controls change things for the user, especially that tablet one with the floor plan?
Yeah, those packages are really interesting because they shift the focus from technical commands to something much more intuitive, visual management. Take that sports bar manager, game night, super busy. Instead of messing with input numbers and output numbers, they pull up a tablet, see a map of their bar, see all the TVs, and they just tap the screen for the game feed, drag it over to the icon for TV number 12. Done. It hides all the complexity. Lets non-technical staff manage dozens of screens easily, quickly, make changes on the fly. Less training, fewer mistakes. It just makes a really complex system feel simple to run.
That sounds incredibly useful, way less stressful for the staff. But it does bring up another question. With maybe 32 different sources, 32 different screens, potentially from different brands, how do you make sure they all actually work together, that the picture shows up correctly everywhere?
Ah, yes. That's where advanced EDID management becomes absolutely critical. EDID, extended display identification data. It's like a little name tag each display wears. It tells the source device, here's what I can handle: resolutions, refresh rates, audio. If that communication goes wrong, you get problems. Blank screens, wrong resolution, picture doesn't fit. Frustrating stuff. So the WolfPack has strong EDID tools. You can tell it, okay, pretend all displays are this specific type, ensuring compatibility. Or it can learn a display's info and copy it for the sources. It basically smooths out that electronic handshake between devices, gets rid of those headaches, especially when you mix and match gear. Make sure you get a good picture everywhere. And having all those control options, RS-232, TCP/IP, that also means it plays nice with existing big control systems, like Crestron or AMX that might already be in the building.
Okay, so it's like a universal translator for all your video gear too. Makes sense. So with all this, who actually needs this level of power? The source mentions, well, a pretty wide range. Corporate boardrooms, conference rooms, auditoriums, command centers, but also sports bars, casinos, bowling alleys, entertainment venues too. Can you maybe pick one or two of those and paint a picture? Like, how does this WolfPack really change things day to day in, say, a casino or a command center?
Sure. Let's take a casino floor. They might have dozens, maybe hundreds of screens showing promotional videos, maybe sports feeds in a lounge area, jackpot announcements, wayfinding information. They need to instantly switch content on specific screens or groups of screens. Maybe trigger a big winner graphic across a whole bank of displays. The WolfPack lets them manage that complex visual choreography reliably, keeping the energy up, keeping people engaged. Fast switching is key there too, no dead air. Or shift gears to a government command center, totally for context. Here, it's about critical intel. Analysts pulling up drone feeds, maps, secure video calls, data streams, all from different secure networks. They need to display precisely the right information on specific screens for the decision makers, instantly. With zero tolerance for glitches or delays, lives could literally be on the line. The WolfPack acts as that central hub, that nervous system, making sure the right visual intelligence gets exactly where it needs to go, when it needs to get there. It's fundamental to the operation.
Wow. Yeah, those examples really highlight why this kind of tech exists. Okay, let's quickly touch on a couple of practical details. The name itself ends with tariff-free. That seems specific. And the price mentioned is $1,750, marked down from $2,250 MSRP. How important are things like tariff-free or being TAA compliant, which is also mentioned for the organizations buying this kind of gear?
Oh, for the target buyers, those aren't just footnotes. They can be major decision points. Tariff-free directly impacts the bottom line. especially on large orders. It means predictable costs, simpler importing, potentially significant savings, less budget hassle. And TAA compliant, that stands for Trade Agreements Act. Super important for government buyers, federal, state, local, and often for large corporations doing government work. It certifies the product is made in the U.S. or an approved country. Often it's a mandatory requirement. If a product isn't TAA compliant, it might not even be considered no matter how good it is technically. Seeing fully assembled and tested adds confidence too. And knowing the company, HDTV Supply, has been around 24 years, is an HD-based adopter that signals stability and expertise. Important when you're buying core infrastructure.
Right, so those details are actually pretty strategic, offering cost benefits and ticking essential procurement boxes for big buyers.
Okay, wow. We have definitely gone deep on the WolfPack 4K 30Hz 32x32 HDMI Matrix Switcher today. We've hit the huge 32x32 capacity, why that specific 4K 30Hz 4.2.20 makes sense professionally, the brilliance of that modular, hot-swappable design for uptime, and those surprisingly slick control options. So what's the takeaway for you listening? Hopefully you've got a much clearer picture now of the kind of sophisticated tech that's working behind the scenes, managing all the visuals around us, from your local sports bar to those critical command centers. It really shows how engineering tackles these complex, high-stakes visual problems.
Yeah, and it really makes you think, doesn't it, as we move towards things like, I don't know, more augmented reality, more immersive visuals everywhere, even more real-time data. How do systems like this WolfPack need to evolve? What's the next step? What kind of new inputs or outputs might they need to handle down the road? What kind of complex visual, maybe even multi-sensory problems will this kind of tech be solving in, say, 5 or 10 years? That is a great question to chew on. Well, thank you for joining us on this deep dive into professional AV signal management. Until next time, keep that curiosity